right, sorry about that. I got cut off at the end of that video because I ran out of time. A little long-winded, I guess. Once again, on this last one, the sum and difference of cubes are the trickier ones. You've got to find the binomial factor first by cube rooting each term, and then take that binomial factor, and to get the trinomial, you take the first term of the binomial, 2x in this case, and you square it. 2x times 2x is 4x squared. Take the last term in the binomial, 5, and square it. 5 times 5 is 10, or 25, excuse me. And then multiply the 2x and the 5 together and give it the opposite sign in the middle. 2x times 5 is 10x, but it needs to be a minus 10x in the middle. So third, after checking for special cases, sum or difference of cubes, difference of squares, or perfect square trinomial now, the third step is if the polynomial has 3 terms, then we want to ask ourselves how we go about factoring, how we can best go about factoring that trinomial. And we've looked at lots of examples here today that reinforce the different methods that can be used to unfoil a trinomial. So these are some you might want to try on your own, and pause the video. This is a trickier one because, of course, 30 is our leading coefficient and it has lots of factors. 5 is our last coefficient, our last term, and that only has 2 factors, 1 and 5. After trying it on your own, you'll find that it factors down to that. Here we have a leading term of 1, so this is a little bit easier to try to factor. There is no GCF. But it does factor down to a t squared first in each binomial, because t squared times t squared is t to the 4th. And then the only factors of 2 are 2 and 1. To check, though, be sure that the outside product, in this case 1t squared, plus the inside product, 2t squared, add up to the middle term, 3t squared. Fourth, if the polynomial has 4 or more terms, then you should consider factoring by grouping. Examples are if you see something like this. The 2 factors on the right side of the equal sign, what they have in common are b plus c. If you factor out the b plus c, you'll be left with the a plus 4. And then if none of those previous 4 methods applies or can be used, it's possible that the polynomial is not factorable. And in that case, then, we call it a prime polynomial. In this case, it's a trinomial, no greatest common factor, leads with a leading coefficient of 1. So the binomials would have to both begin with x, because x times x is x squared, but we would then need factors of 12 that add up to 5. Well, 1 times 12 is 12, those add up to 13. 2 times 6 is 12, those add up to 8. 3 times 4 is 12, those add up to 7. There are no factors of 12 that add up to 5. Therefore, it's not factorable using the integers. As always, do not hesitate to message me if you've got any questions. I'm here to help.